Somewhere inside the equations physicists use to describe everything that exists, there is a quiet, almost embarrassing detail. The mathematics knows how things change. It knows how particles move, how energy shifts, how waves rise and fall through space. But nowhere, in any of the core equations, is there a line that tells reality how to stop. There is no symbol for ending, no instruction for vanishing. The universe, as far as the math can tell, only knows how to continue. And if that is true, then the thing you call yourself, the soft hum of awareness behind your eyes, may be tangled into that continuation in ways no one has fully understood. Welcome in. Settle wherever you are. Loosen your shoulders, soften your breath, and let the room around you grow a little quieter. If these slow, late-night explorations help you rest, you might consider staying with the channel for the nights ahead. Nothing urgent, just a gentle companionship in the dark. Tonight, we are going to drift, slowly, into one of the strangest ideas in modern physics. An idea whispered between equations and thought experiments, debated in quiet corners of theoretical research. It suggests that the word death, as we usually mean it, may not fit cleanly into the deeper layers of reality. Not as a promise, not as a certainty, only as a possibility worth sitting with. So let your thoughts loosen just a little. We are stepping through a door that, according to the equations, was perhaps never fully closed to begin with. Rest your hand somewhere comfortable. Feel its weight, its warmth, the small, steady pressure of skin against fabric or air. It feels solid, reliable, a clear, definite thing in a clear, definite place. And yet, if you could zoom in, past the skin, past the cells, past the molecules, past even the atoms, you would slowly run out of solidity altogether. You would find, instead, something that behaves less like a thing and more like a quiet suggestion of a thing. At those tiny scales, the particles that make up your hand do not sit still in fixed locations. They behave in a way like ripples on a pond, smeared out across small regions of space, more like a soft cloud of possibility than a hard little ball. Physicists describe this with the idea of wave-particle duality, the strange observation that the smallest pieces of reality act sometimes like points and sometimes like waves. Depending on how we look at them, they are not quite one thing. They are not quite the other. They are something in between, something our language was never really built to describe. There is also a quiet rule called the uncertainty principle. In very simple terms, it says that for these tiny pieces of reality, you can never know everything about them at the same time. The more precisely you pin down where a particle is, the less you can know about how it is moving, and the more sharply you track its motion, the more its location blurs. It is not a limit of our instruments. It seems to be woven into the fabric of nature itself. Sit with that for a moment. The hand resting in your lap, the body lying in bed, the chest rising and falling with your breath, all of it, at its deepest level, is not made of little marbles arranged neatly in space. It is made of tendencies, likelihoods, soft probabilities humming quietly beneath the surface of every solid feeling. This is not a trick of language. Experiments have shown again and again that at small enough scales, particles really do behave like blurry possibilities rather than fixed objects. The shapes we see, the textures we feel, the faces we recognize, emerge from countless tiny uncertainties that somehow add up, at our scale, into the appearance of something firm. There is something gentle in that, if you let it land. The body you are inhabiting tonight is not the rigid, brittle thing it sometimes feels like in the day. It is, at its roots, a quiet shimmering, a pattern of probabilities holding hands long enough to look like you. Some have wondered whether this softness at the base of reality might also soften some of our heavier assumptions about what it means to begin and end. If solidity itself is a kind of story the universe tells at larger scales, then perhaps endings too are partly a story, drawn from a deeper texture we do not yet fully understand. For now, we are only noticing, only listening. The hand rests, the body rests, and underneath it all, something quietly continues to hum. Here is a small, strange fact that physicists have been quietly arguing about for nearly a century. When no one is watching a tiny particle, it seems to behave like a wave, spread out across many possibilities at once. But the moment something measures it, the moment some kind of observation enters the picture, the wave appears to collapse into a single, definite outcome. The wide cloud of maybe becomes a sharp point of is. This is sometimes called the measurement problem, and it sits, awkwardly and beautifully, at the very center of quantum physics. Nobody fully agrees on what counts as a measurement. Is it the click of an instrument, the interaction with another particle, the arrival of light, or, in some interpretations, the quiet presence of a conscious observer? You can feel how unusual this is. In the world we are used to, the moon is the moon whether you look at it or not. The chair is in the corner whether anyone is in the room, but at the smallest scales, the act of looking does not seem to be neutral. Looking somehow participates. Now turn that gently around. You, lying here, breathing, are not standing outside of reality, peering in. You are, in some sense, an observer woven into the very thing you are observing. Your thoughts, your awareness, the faint glow of self-recognition behind your eyes, all of it sits inside the same fabric the equations describe. Many say that consciousness has no clean place in physics. It is not in the standard equations. It is not predicted by the basic forces. And yet, here it is, undeniable from the inside, the only thing any of us ever experience directly. Every theory you have ever read about the universe arrived in your mind through the quiet doorway of awareness. Without that doorway, the equations have no one to speak to. This leads to a soft, almost dizzying thought. If observation plays some role in shaping what becomes definite, and if you are an observer woven into reality, then your awareness may not be a small accident perched on top of the cosmos. It may be tangled into the loom itself, in ways physics has not yet learned to describe. This does not mean your mind reshapes mountains or rewrites the past. It means, perhaps, that the relationship between mind and matter is more layered than the simple picture of a brain producing thoughts inside a skull. Some physicists explore models where information, observation, and the structure of reality intertwine. Others prefer interpretations where consciousness plays no special role at all. The honest answer is that no one yet knows, and that uncertainty is part of the wonder. The mirror you look into each morning is also looking back, in a sense, through the very particles that make up your eyes. The observer and the observed are not as cleanly separated as they appear. So tonight, as your eyes soften, notice how unusual it is that anything is being noticed at all. The whole strange architecture of being seems to lean, ever so slightly, on the quiet fact that you are here, aware, paying attention, even now, even in the drowsy hush before sleep. There is a thought that often arrives late at night, when the room is dark and the mind is wandering. It is the gentle realization that none of the material that makes up your body was made for you. None of it was crafted on the day you were born. Every atom inside you is far, far older than your name, your face, your story. Most of it is older than the planet you are lying on. Almost all the atoms in your bones, your blood, your skin, your breath, were forged in the cores of stars. The carbon in the soft tissue of your hand, the oxygen in every cell, the iron quietly carried in your blood, the calcium humming inside your teeth, all of it was once part of stellar furnaces, burning at temperatures we cannot really picture. Stars lived their long lives, fused light elements into heavier ones, and when some of them died, they scattered those new elements outward in vast glowing clouds. Those clouds eventually became other things. Dust, rock, oceans, trees, animals, you. The story of the elements inside you is not the story of one lifetime. It is the story of generations of stars, ancient explosions, slow gravitational drifts across galaxies, and finally, an astonishing arrangement of those atoms into the configuration that is reading or hearing these words tonight. Many say that we are made of stardust, and it sounds almost like poetry, but the science behind it is surprisingly precise. Stellar nucleosynthesis, the process by which stars build heavier elements out of lighter ones, is one of the most carefully studied chapters of physics and astronomy. The numbers match, the patterns match, The very ratios of elements in your body echo the patterns we see in old stars and the remains of supernovae. Now let that settle into something softer. The atoms inside you tonight have already lived through unimaginable journeys. They have existed for billions of years. They have been part of clouds, planets, perhaps other living things long before you. And here is the quiet wonder. When, one day, this particular arrangement of them finishes its current shape, those atoms will not vanish. They will continue. They will become rain, roots, air, new cells in unfamiliar bodies, new patterns we cannot picture. Nothing about that requires any particular belief. It is simply how matter behaves at this layer of reality. Atoms are remarkably stable. They do not blink out of existence when a body's story ends. They are passed onward, woven into other arrangements. The way letters in a book are reused to write entirely new sentences. There is something gentle in noticing this. You are, in a very real sense, a temporary gathering of very ancient material. The U shape is recent. The substance is ancient. And whatever the equations of identity might one day reveal, the quiet truth is that the particles humming inside you have already practiced continuation for far longer than any one life could imagine. Tonight, your breath moves star-born atoms in and out of your chest. The same kind of matter that once glowed in distant suns now warms a small room, holds the weight of a blanket, and slowly, softly, prepares to rest. Imagine the body as a kind of slow river. From the outside, it looks like the same river you have known for years, the same banks, the same shape, the same general flow. But the water inside it is never quite the same water. New molecules pour in. Old ones drift out. The river holds its identity not by clinging to specific drops, but by holding a steady shape while the substance inside changes constantly. Your body works in a strangely similar way. Most of the cells in you now were not in you a few years ago. Your skin renews itself in weeks. The lining of your stomach replaces itself far faster. Bone, muscle, and blood are all part of ongoing cycles of removal and renewal. Even within cells that last longer, the molecules inside them are continually swapped, repaired, rebuilt. The body you call yours is, in a sense, a slow-motion replacement, happening so gently that you never notice the changing, and yet something feels continuous. Memories carry from year to year. A childhood moment can still light up inside you decades later. Your name still answers to you. The voice in your head still feels like the same voice. How can identity feel so steady when the physical material keeps refreshing itself underneath? This is where a quiet idea enters, sometimes called pattern identity. It suggests that what you really are is not the specific atoms or cells, but the pattern they form together, the arrangement, the dance, the information humming through that arrangement. As long as the pattern continues gently updating itself, you continue. The substance moves through, but the shape of you remains. Think of a flame on a candle. The flame is always there, recognizable, almost personal in its flicker. But the actual material of the flame, the gas and heat, is constantly being replaced. New fuel rises, new heat radiates outward, old combustion drifts away. The flame is not a thing in the old sense. It is a process that keeps a certain pattern alive. You may be more like that flame than the candle holding it. The cells flow, the molecules change, but the pattern persists, repeating itself a little differently each moment, yet recognizably you. Now turn this gently in another direction. If you are a pattern, then the question of what happens when that pattern is disturbed becomes deeper than the simple picture of a body switching off. Patterns do not necessarily live in one place only. The information that defines a flame depends on the conditions around it. The information that defines you depends on the structure of your brain, your memories, your relationships, even the imprint you leave on others. Some thinkers have wondered whether identity is fully contained inside one head, or whether it leaks ever so slightly into the wider world. We are not making promises here. No one has resolved these questions. Yet the soft observation remains. The self you carry tonight is already not the self of years ago, atom by atom. You have already, quietly, lived through many subtle transformations, and still, here you are, settling under the blanket, the same and not the same, like a flame holding its shape through endless small renewals. Most of us picture time as a thin, straight line, a road stretching from the past to the future, with the present moving across it like a single bright point. The past disappears behind us, the future has not arrived. Only this thin sliver, called now, feels real. It is a simple picture. It is also, according to physics, perhaps not quite right. Einstein's theory of relativity changed our understanding of time in a quiet but profound way. Time, it turns out, is not the same everywhere. It bends, it stretches, it slows down for fast-moving objects, and shifts subtly near strong gravitational fields. A clock on a fast plane will tick a tiny bit slower than a clock on the ground. A clock at the bottom of a mountain runs slightly differently than one on the peak. Tiny effects, almost too small to feel, but real, measured, confirmed. This already softens the line. Time is not a universal ribbon stretched cleanly through the cosmos. It is more like a texture, woven differently for different observers, depending on how they move and where they are. Two people can experience the same events in slightly different orders. There is no single universal now that holds for all of reality at once. Some physicists, taking this further, work with a picture sometimes called the block universe. In this view, past, present, and future all exist together as a kind of four-dimensional shape. From inside that shape, moving along your own path, you only ever experience one moment at a time. But the whole structure, the entire fabric of events, might already be there in some deeper mathematical sense, the way every point on a long road exists at once, even if a traveler only sees one at a time. This is one possible interpretation, not a settled truth. Other physicists prefer pictures in which the present is special and time genuinely flows. The debate is open and quietly ongoing. Even just sitting with the block universe as a possibility shifts something gentle inside the mind. If it were true, then no moment ever fully vanishes. The moment you first laughed as a child, the afternoon light through a window you no longer remember clearly, the small, ordinary morning earlier today, all of them might still exist, frozen into the geometry of space-time, even though you can no longer walk back to them. Here is the soft twist. From inside, you would still feel time passing exactly as you do. The flow you experience would not be an illusion you could see through. It would be the natural feeling of moving along your slice of the larger shape. The river of time feels like a river because you are inside it, not standing outside the whole landscape. Notice how this small shift changes the weight of certain words. Lost, gone, over. In a block universe picture, these become more about your position than about the events themselves. The moments you have lived are not erased. They are simply behind you on the path. Present, you cannot return, but the moments themselves may still be quietly held in the wider structure. Whether or not this picture is the right one, it offers a hint. Time may be less of a knife and more of a texture, and what we call endings may be less sharp than the line of now suggests. There is a strange habit in nature that physicists noticed long ago. Information, in its deepest sense, does not seem to like to disappear. You can burn a book, and yet, in principle, all the information about every molecule, every page, every ink stroke is still encoded in the smoke, the heat, the patterns of vibration moving outward. The original arrangement is lost to you and to anyone reading, but the universe, in a deep mathematical sense, still seems to remember. In quantum physics, this idea is captured by something often called the conservation of information. The equations that govern how systems evolve do so in a way that, in principle, lets you trace everything backward from any final state to its starting point. The universe's laws at this level treat information almost the way we treat energy, not as something that vanishes, but as something that flows, transforms, redistributes itself, but never quite ceases to exist. This sounds abstract, but it is a serious commitment in modern physics. So serious that when it appears to be violated, physicists treat it as a deep problem rather than a casual curiosity. The most famous example is the black hole information paradox. When matter falls into a black hole, Simple early reasoning suggested that all the detailed information about it might be lost forever, swallowed by the dark interior, eventually leaking away as featureless radiation. But a universe that allows information to truly disappear would clash with quantum theory's deepest rules. So a long, careful debate began. Many theoretical physicists now argue that information is not actually destroyed in black holes. Even if it becomes scrambled almost beyond recognition, it may be encoded in subtle correlations in the radiation that slowly trickles out, or in unfamiliar geometric properties of spacetime itself. The details are still being worked through, and humility is essential. No final answer has emerged, but the very fact that the question is taken so seriously tells us something. Even in the most extreme places we can imagine, the universe seems reluctant to let its records vanish entirely. Now, hold that softly against the thought of a life. You are, among other things, an immense pattern of information. Every memory, every preference, every relationship is, in some sense, structure, arrangement, patterns of matter and energy that took years to organize. None of this needs to be reduced to cold equations to feel its weight. The shape of who you are is its own kind of quiet wonder. We are not claiming here that there is a tidy bridge between black hole physics and personal continuity. That would be a leap far beyond what current science can support. But there is something worth noticing in the broader pattern. The universe, at its deepest mathematical level, behaves like a place where the past is not casually erased. Configurations may scramble, scatter, transform, become impossible for us to recover, and still, in the deeper bookkeeping, information seems to persist. It is a strange comfort, not a promise, not a doctrine, only a hint, woven through the equations, that the cosmos is not in a hurry to forget anything. Each moment you live, each thought that drifts behind your closed eyes tonight, leaves its trace in a fabric that does not seem to know how to fully erase. You have probably heard of Schrödinger's cat, the famous thought experiment with the sealed box, the cat inside, and a quantum trigger that, according to the rules of quantum physics, leaves the cat in a strange state where it is somehow both alive and not, until someone opens the box and looks. It often gets told as a puzzle, a paradox, a clever joke at the universe's expense. But Schrödinger did not invent this scenario to amuse anyone. He proposed it as a quiet protest, a way of saying, look at how strange the equations become when we apply them to something larger than a single particle. He was less interested in giving us a cute story and more interested in shaking us gently, asking us to take seriously how unusual the quantum world is. Inside that thought, there is an idea sometimes called superposition. In simple terms, it means that at very small scales, a system does not have to choose. A particle does not need to be in just one place. It can exist, in some mathematical sense, in a blend of possibilities at the same time. It is not that we do not know which one is true. It is that, until something interacts with it, the system itself seems to hold several outcomes together, like several musical notes layered in one chord. In the lab, this is not a metaphor. Experiments with electrons, photons, and atoms have shown again and again that quantum systems behave as if multiple possibilities coexist, and only when a measurement happens do we see a single result. The patterns that emerge can only be explained if the system genuinely carried more than one possibility before being observed. Now, the cat itself is not a real experiment, of course. No one is actually sealing cats in boxes. The point Schrödinger was making was that if we take the equations at face value, this strangeness should not stop at the atomic scale. It should, in principle, reach upward into larger systems. The fact that we do not usually see cats in eerie blended states tells us that something complex happens between the quantum world and our everyday one. Physicists have spent decades trying to understand that something. Several interpretations have arisen. Some suggest that observation, in some way we do not yet fully grasp, forces a choosing. Others propose that interactions with the wider environment quickly smear the possibilities into one apparent outcome. Others suggest that all the possibilities remain real in their own way, and only our perspective selects one to live inside. None of these is settled. What stays with us, beneath the debates, is the suggestion that at the quantum layer of reality, the universe does not always commit immediately. It holds options. It allows multiple unrealized states to coexist for a while. It is not as quick to decide as our everyday intuition assumes. This is a beautiful thought to carry into the chapters ahead. If parts of reality hold multiple possibilities at once, then maybe the picture of a single fixed life moving along a single fixed line is itself a simplification. Maybe what we experience as a singular path is one thread inside a much richer weave, one note sounding inside a softer, broader chord. For now, no conclusions, just an opening. The box, in a strange way, may never have been fully closed. Some ideas in physics arrive quietly and then refuse to leave. The many worlds interpretation of quantum mechanics is one of them. It was first proposed in detail in the 1950s by a young physicist named Hugh Everett. He was not trying to write a science fiction story. He was trying to take the equations of quantum mechanics seriously, all the way down, without inserting any extra rule that suddenly collapsed possibilities into one. In standard pictures, when a quantum system is measured, we say the wave function collapses. The cloud of maybe becomes a single outcome. But this collapse is not really written into the core equations. It is added on top, almost like a polite afterthought, to make the math match what observers see. Everett asked a simple, strange question. What if collapse never actually happens? What if all the possibilities continue to evolve, side by side, forever, with the universe quietly branching into many threads each time a quantum event might have gone different ways? In this view, every time something at the quantum scale could go one way or another, reality, in some sense, does both. The branches separate so completely that they no longer interact, and observers inside each branch only experience their own version of events. Nothing inside a branch ever sees the others. From the inside, life looks completely normal. From outside, if any such outside existed, the whole structure would be a vast, ever-branching tree of possibilities. This is one interpretation. It is not proven. It is not the only respectable view. Some physicists find it elegant because it requires no extra collapse rules. Others find it extravagant because it asks us to accept an enormous, unseen multiplicity. The debate is real, and it is honest. The honest summary is that there is currently no experiment that can decide between the major interpretations of quantum mechanics. Yet many worlds keeps whispering, because it offers a way to read the equations without quietly inserting magic. It treats the wave function as fully real, and lets the universe carry every outcome that the equations allow. In that sense, it is almost the most literal reading of the math. Even if it seems strange to our everyday intuition, imagine the difference for a small choice. The light turning green half a second sooner or later, a glance lifting at just the right moment, a breath taken differently before a hard word was spoken. In a world where some of these tiny moments depend, eventually, on quantum-scale events, the many worlds picture would suggest that the unchosen versions are not nothing. They are not erased. They simply belong to other branches, where other selves carried on inside other paths. You can feel how heavy this could become if held too tightly. So we hold it gently, as one possibility among several. We are not declaring it true. We are noticing, calmly, that one serious interpretation of modern physics paints reality as a vast tree of unfolding alternatives. If that picture is even partly accurate, the question of endings becomes far more layered. A particular branch may close, a particular thread may quiet, and yet the wider fabric in this view would continue to unfold elsewhere, holding patterns and possibilities that no single observer could ever see. A whisper, not a promise, but a whisper worth listening to in the dark. If the previous idea was a whisper, this one is a quiet question often asked in late-night corners of physics forums. It carries an unusual name: quantum immortality. It is not a theory, it is not a doctrine, it is a thought experiment, born from taking the many worlds picture very, very seriously, and then asking what it might mean for the experience of being someone. Here is the gentle version. Suppose every quantum event splits reality into branches. Suppose, for the sake of imagination, that some critical moments in your life depend in tiny ways on quantum-scale events, a subtle electrical fluctuation in a cell, a microscopic flicker in a complex chain of biological steps. If those moments branch, then in some branches the difficult event happens, and in others it passes differently. Now consider an observer inside this picture. You only ever experience the branches where you are still here to experience anything. The branches in which experience continued naturally are the only ones from which you can look back and tell a story. The branches where experience ended cannot speak. From inside, your view is always filtered through the simple fact that you are still here. Some have argued that, taken at face value, this could mean an observer always finds themselves in a thread where they continue, not because something protects them, not because the universe favors them, but simply because their experience can only be lived where it is still being lived. The threads where it stopped are invisible from the inside. This idea sounds startling, and it should be held very carefully. Many physicists are deeply skeptical of it. It depends on assumptions that are far from proven, including whether the many worlds interpretation is correct, whether consciousness aligns neatly with quantum branching, and whether the math behaves the way the thought experiment suggests. The honest position is that this is speculation built on top of speculation, fascinating to think about, but not a claim to bank one's life on. Still, there is something worth noticing here, even gently. The thought experiment is not really about avoiding endings in any practical sense. It is about how strange it becomes, philosophically, to ask what happens to me inside a framework in which experience itself may select the branches it inhabits. It nudges us to wonder whether the simple, single-thread picture of life we usually carry might be a useful illusion rather than a complete one. Most days this kind of question is too large to be useful. It does not change how you live. It does not change how you love. It does not change how you care for the body you are in. The ordinary truths of kindness, presence, and gentleness remain. Whatever the deeper structure of reality, your life as you experience it is still precious, still finite from the inside, still asking to be lived with care. But late at night, with the room dark and the day's noise softened, it can be a quiet companion to consider that the equations leave room for stranger possibilities than the daylight usually admits. Not as a promise, not as a comfort to grasp tightly, only as a hint that the end may not be the simple, clean concept our language pretends. Somewhere, in the gentlest reading of the math, there may always be a branch where the candle in some form is still lit. In the daylight, we like certainty. We want clear answers, yes or no, open or closed, alive or gone. Our language is full of sharp lines, and our days are full of decisions that feel like they must commit to one side or the other. But the universe, in its deepest mathematics, speaks a softer language, the language of probability. At the quantum scale, you do not say that a particle is here. You say that it is more likely to be found here. You do not say that an event will happen. You say that it has a certain amplitude, a certain weight in the wider pattern of possibilities. The rule that connects these patterns to what we observe is sometimes called the Born rule. It tells us how to turn the mathematical waves of possibility into the actual frequencies of outcomes we see in experiments. This is not because nature is hiding the true answer behind a curtain. It is, as far as we can tell, the way reality is structured at that level. The world is built out of likelihoods, not certainties. Outcomes emerge from waves of possibility that interfere, blend, and shape each other. The way ripples in a pond can either reinforce or cancel one another. There is something tender in that, if you let it settle. The harshness we sometimes feel in life comes, in part, from the picture of a universe filled with sharp, unforgiving outcomes. This happened. This did not. This is real. This never was. But the quantum world does not really speak that way. It speaks in shades, in weights, in leanings, in gentle distributions across a wide field of maybes. Consider what this might mean for the events of an ordinary life. From inside, a moment feels singular. You either caught the train or you did not. You either spoke the kind word or you did not. The clock ticked one specific number. The decision landed one specific way. And yet, At the deepest layer of the mathematics that physicists use to describe reality, every outcome that could have happened still carries some amplitude, some weight, some quiet existence in the structure of the wave function, even if that weight is too small for us to ever notice in daily life. This does not mean that everything imaginable is equally true. The probabilities are real and unequal. Some outcomes are vastly more likely than others. The universe is not random in a careless sense. It is, in a way, careful, patterned, lawful. But within those laws, it leaves room for a wider field of possibility than our sharp words usually admit. Many say that this is one of the reasons quantum physics feels so strange. It asks us to give up the clean certainty we wanted and to live, conceptually, inside a field of weighted possibilities. But once that strangeness softens, there is a kind of generosity in the picture. The harsh edges of single outcomes blur slightly. The story of a life becomes less like a line drawn on paper and more like an ink stain, dark in the middle, fading at the edges, surrounded by quiet halos of all the ways it might have been. So perhaps probability is not coldness. Perhaps it is a kind of tenderness. A way the universe declines to be cruel about what could and could not have been. Outcomes are real, but they sit inside a wider mathematical embrace. There is a feature of quantum physics that even Einstein, who helped invent so much of modern physics, found quietly unsettling. He called it spooky action at a distance. The technical name is entanglement, and it remains one of the most carefully verified and most philosophically strange features of the natural world. Here is the gentle picture. Two tiny particles can interact in such a way that they become linked. From that point on, even if you move them very far apart, even across vast laboratory distances, certain measurements on one are perfectly correlated with measurements on the other. You measure one in a certain way, and the result of the corresponding measurement on the other is, in a sense, already woven into the outcome. The two are no longer fully independent. They are, mathematically, one shared system stretched across space. Many people imagine this as some signal traveling between them, faster than light, whispering instructions. But careful experiments and theoretical work suggest something quieter and stranger. No usable signal is being sent. You cannot use entanglement to send a message in any normal sense. And yet, the correlations between the two particles are stronger than any explanation rooted in classical physics can allow. A physicist named John Bell proved this with remarkable precision in the 1960s, in what is now known as Bell's theorem. Experiments since then, refined again and again over decades, have confirmed that nature really does exhibit these correlations. Whatever entanglement is, it is not a fluke. It is a feature. What this gently tells us is that the idea of two things being fully separate, fully independent, may be less clean than common sense pretends. At the quantum level, reality seems to allow connections that do not respect the usual sense of distance. The two particles are not really two private islands. They are part of a single mathematical pattern, even when far apart. Now, before this turns into something larger than it should, a careful note. Entanglement does not mean that people are mystically connected at a distance in some literal physics sense. The kind of entanglement we have measured in labs typically involves very delicate states that are easily disturbed by interactions with the environment. Everyday objects, including human bodies, are very complex and quickly interact with their surroundings, which destroys the kind of clean entanglement that experiments rely on. So the romantic image of two minds quantum entangled across continents is not directly supported by the physics. What is supported is something perhaps deeper and certainly stranger. The very fabric of reality, at its most fundamental layer, allows for relationships that do not fit the picture of strictly separate objects. Separation is real, but it is not absolute. It is more like a layer of structure on top of something more deeply unified. There is a quiet comfort in that. The world we live in does not draw its dividing lines as sharply as our minds sometimes do. The particles that once shared an interaction carry a quiet record of that shared past. The fabric of space-time appears to be threaded with such relationships, almost without end. So when you think of all the things you have touched, breathed, looked at, spoken with, It is not absurd to feel that you have brushed against a world that, deep down, does not really know how to be fully apart. The threads between things are subtler than they look. Some thinkers, when they look at the equations of quantum physics, notice something that almost feels like a hint about the nature of reality itself. The world seems to behave less like a collection of solid stuff arranged in space, and more like a vast, evolving pattern of information. Bits flipping, states shifting, probabilities updating, all woven together by mathematical rules. The physicist John Wheeler captured this idea in a famous phrase, "it from bit." His suggestion, framed in his own careful and humble way, was that physical things, the its of the world, might in some sense emerge from underlying information, the bits, the matter we see, the forces we feel, the empty distances between stars, might all be expressions of a deeper computational fabric we have not yet learnt how to read. This is not a settled theory. It is a perspective, an interpretive lens, one of many. Other physicists prefer to treat information as a useful tool we use to describe reality, rather than as reality's ultimate substance. The honest summary is that no one has demonstrated that the universe is literally a computer in the way our laptops are. What is increasingly accepted is that information sits at the very heart of how the deepest equations behave. There is a quieter version of this insight that does not depend on any specific theory. Even in standard quantum physics, information seems to be a fundamental currency. The states of particles are described by information. The conservation laws act on information. The structure of space-time, in some recent theoretical work, may itself be related to patterns of how information is shared between regions. The deeper physicists dig, the more reality starts looking like a place where stuff and information are not really separate. Imagine for a moment the universe not as a vast, empty hall full of solid things, but as a giant, slow-moving piece of music. Every note depends on every other. Every pattern carries information that shapes what comes next. The instruments are not separate from the song. They are aspects of the same unfolding pattern. In such a picture, the question, "What is this thing made of?" becomes harder to answer in the old way. It is made partly of how it relates. It is made partly of the information it carries about itself and others. Now consider what you are inside such a picture. You are not just a small clump of matter pinned to one corner of an indifferent universe. You are a deeply structured pattern, woven through with vast amounts of information. Your memories, your habits, your relationships, your way of seeing the world, all of it is a kind of intricate code humming inside the bigger code. Whether or not the universe is literally computational, you are clearly informational. This does not magically dissolve the mystery of endings. Information in our equations may persist in subtle ways, but the pattern that is you, as you experience it now, depends on a very particular arrangement that takes constant work to maintain. We are not promising eternity. We are only noticing how strange and rich the picture becomes when information is taken seriously. If reality is, in some sense, busy computing itself into existence at every moment, then your life is a small but intricate program running inside that vast process. Tonight, that program slows. Lights dim, patterns soften, and the larger calculation continues gently all around you. Every night, something extraordinary happens to you, and you barely notice. You fall asleep. The room goes quiet. Your eyes close. Your breathing slows. And somewhere along the way, the bright stage of awareness goes dark. The voice in your head softens, then disappears. The you that was thinking about the day, planning tomorrow, replaying conversations, simply stops. For long stretches of the night, there is no felt sense of being anyone at all. And then, hours later, it returns. You open your eyes. The sense of self snaps back almost in mid-sentence, as if you had only been gone for a moment. The room is the same. Your name is the same. Your story is the same. The interruption is not even remembered. This nightly performance is so familiar that we forget how strange it is. From the inside, your life feels like an unbroken thread. But from a scientific point of view, sleep is full of remarkable transformations. The brain shifts through different states. Some stages are filled with vivid dreams, others with deep, slow waves. Memory systems are quietly busy, sorting, consolidating, filing the experiences of the day. Connections between neurons are gently rearranged, pathways are pruned. The brain that wakes up is, in subtle ways, not quite the same brain that fell asleep. If identity were truly tied to one specific moment-to-moment continuity of conscious awareness, the gaps of dreamless sleep should be unsettling. There are stretches during the night where awareness, as far as we can tell, simply is not. Yet you do not feel that you ended last night and a stranger took over this morning. You feel that you are the same person who once again opened their eyes. This suggests something quiet and important. The continuity of self does not seem to live in an unbroken stream of conscious experience. It seems to live in the pattern that the brain and body keep restoring. When you wake up, your memories return, your habits return, your way of perceiving the world returns. The pattern reassembles itself, and the reassembled pattern feels seamlessly like you. In other words, you have already practiced every night a small version of what some of the deeper questions in physics keep circling. The pattern that is, you can pause in some sense and resume. The thread feels continuous, even though the underlying experience is not. Many people, when they think about endings, picture them as the moment the light of awareness simply switches off. But the truth is that switching off, in a small way, happens often. It happens in deep sleep. It happens under certain medical procedures. It happens in moments of so-called blank time. And every time, the pattern has so far returned. This is not, of course, proof that all forms of pause can be resumed. Some interruptions to the body and brain are very different from sleep. We must be honest about that. Yet there is something gentle in noticing that the simple picture of constant, uninterrupted awareness equals being alive is already not how your existence actually works. You are, in your usual life, a being who repeatedly comes back from the quiet. So tonight, as the day's noise softens, notice the bravery hidden inside the simple act of sleeping. You are quietly trusting that the pattern can resume, and night after night, so far, it has. When you try to point to where you live, things become surprisingly slippery. You might say naturally that you live in your head, behind your eyes, but if someone asked you to be more precise, which neuron exactly, which exact cluster, which specific group of molecules, the question would start to feel strange. Nothing in your skull is wearing a label with your name. There is no single command center that, if you tilted your head just right, would shine clearly as the seat of self. Modern neuroscience has spent decades searching for what are sometimes called the neural correlates of consciousness. The idea is to find the patterns of brain activity that reliably accompany conscious experience. And while scientists have learned an enormous amount about which areas light up during attention, perception, emotion, and memory, no one has yet pointed to a single specific place and said, this is where the self is stored. Instead, what they keep finding is networks, patterns, coordinated activity spread across many regions, dancing in time, holding the experience of you together. This has led some thinkers to consider what is sometimes called pattern identity. The idea, in its gentle form, is that you are not best understood as a specific lump of matter, but as a particular pattern that matter is currently performing. Your memories are patterns. Your personality is a pattern of patterns. Even your sense of being yourself is, perhaps, a kind of ongoing pattern of self-modeling, a process the brain runs to coordinate its many parts. If this is even partly right, then a soft question opens up. Where does a pattern live? It does not live in a single neuron. It does not live in a single moment. It lives in relationships, in timing, in the way many smaller things move together. And patterns, by their nature, can in principle be supported by different arrangements of matter at different times. Consider a song. The melody of a song is not the same as any one performance. It is not the wood of any specific instrument or the air of any one concert hall. The song is a pattern that can be played on a piano, hummed alone in a car, written on paper, or held in your memory in silence. The substrate changes, the pattern persists. Now place this gently next to the question of endings. If you are a pattern, The question becomes not just what happens to the body, but what happens to the pattern. Some of it we know is held in your neurons. Some of it, perhaps surprisingly, is held in your relationships, your influence, the imprint you leave in the minds of the people around you. The pattern that is you is not a single closed box. It leaks ever so softly into the world. None of this is a tidy answer. The science of consciousness is still young. The philosophical debates around personal identity are old and unresolved. We are not claiming that any one view is correct. We are noticing, gently, that the simple picture of self as a small contained thing inside a head is probably too small. You may be more like a melody than a marble, a weave that the universe is currently performing, a pattern that, even when it eventually changes, is woven into the wider music in ways we are only beginning to suspect. There is a principle in physics that sounds almost too simple to matter until you sit with it. Energy is never destroyed, it only changes form. This is sometimes called the first law of thermodynamics, and it sits, quiet and steady, beneath everything that happens in the physical world. From the burning of a candle, to the running of a heart, to the explosion of a star, the same rule applies. Energy moves, energy transforms, but it does not disappear. You can feel this in small, ordinary ways. The warmth from your hand spreads gently into the air. The food you ate today, once part of plants and animals warmed by the sun, is now warmth in your muscles, electricity in your nerves, light flickering in the patterns of your thoughts. Nothing was created from nothing. Nothing simply vanished. The energy of the sun, captured by living things, became the energy of your existence, and it is, even now, still moving through you, still passing through your body, still flowing outward. A flame is a beautiful, quiet teacher of this. A candle burns and seems, to our intuition, to use up something. The wax shrinks, the flame eventually goes out, but nothing has been destroyed. The wax has become carbon dioxide, water vapor, heat, light. Those things, in turn, will become other things, taken in by leaves, absorbed by air currents, radiated into the larger sky. Every bit of energy is accounted for, even if it is now scattered in places we cannot easily follow. Now hold this against the heavier picture of an ending. From the strict viewpoint of physics, when a body finishes its particular role, no atom and no joule of energy is annihilated. The atoms, as we explored earlier, return to the wider world. The energy disperses into heat, into chemical processes, into the gentle warming of the surrounding environment. The configuration changes, the substance and the energy continue. This is not a poetic exaggeration. It is, in the strictest possible sense, a description of how matter and energy behave. The fabric you are made of is part of an enormous ancient flow that has been running for billions of years. Your particular shape borrows from that flow for a while, takes part in it, then releases it back. The flow itself never stops. There is, of course, a difference between the flow continuing and the specific pattern of you continuing. The energy that warms a cup of tea is not the same as the experience of drinking it. The atoms that once formed a beloved face are not the same as the love itself. We do not want to confuse these layers. The persistence of matter and energy does not on its own promise the persistence of personality or memory, and yet even noticing that nothing is truly lost in the physical sense is a quiet relief. Many of the things we fear losing, at the deepest material level, are not lost in the way our language suggests. They change address, they take new forms. They become part of other patterns we may never recognize. Some have wondered if this is part of why nature can feel both fragile and reassuring. Specific shapes are temporary, but the substance and energy from which all those shapes are made, in their quiet way, simply continue. The universe seems unwilling to truly throw anything away. Here is a strange thought that physicists have been turning over for a few decades now. Imagine a region of space, like the room you are lying in. Common sense suggests that all the information about what is in that room, every object, every particle, every relationship between things, is fully contained inside the three-dimensional volume of the room itself. The room holds itself, but certain theoretical models of physics suggest something quietly astonishing. the information needed to describe what happens inside a region of space might be fully encoded on its boundary rather than throughout its volume, as if the surface around a region somehow holds all the details about what fills it. This idea is part of what is sometimes called the holographic principle. It has emerged in different forms from work in quantum gravity, black hole physics, and certain mathematical relationships explored in string theory and related fields. It is important to be careful here. The holographic principle is not a fully proven law. It is a deep theoretical pattern that has shown up again and again in well-defined models, and many physicists take it very seriously as a clue about how nature might really work at its deepest layers. But it is not the kind of thing we have directly observed in the lab. It is a hint, a suggestion, a piece of a larger puzzle still being put together. Yet, even as a hint, it is a startling one. It quietly questions our intuition that reality is built like a stack of three-dimensional boxes filled with stuff. Instead, it suggests that volume and surface, inside and outside, may not be as clean a distinction as we thought. The whole interior of a region might be a kind of projection from information held on its edge. Try to picture this gently. Imagine a balloon, and imagine that everything inside the balloon, every shape, every dance of particles, is described by patterns spread across the balloon's outer surface. The inside is real, yes, but in some sense the deep description of it lives on the boundary. It is hard to truly visualize because our minds were built to navigate ordinary space, not to imagine information as the basement of everything. Now soften this back into a feeling rather than a technical claim. What the holographic principle suggests in its broadest spirit is that reality may store itself in places and forms our intuition does not naturally suspect. Information might be hidden in surfaces and relationships. The thingness of things may rest on patterns that exist in unfamiliar geometries. It is not unreasonable to wonder gently whether this changes how we think about endings. If patterns and information can be encoded in unexpected ways, then perhaps what we call the loss of something is also, partly, a change of address. The pattern of a life is not stored in one obvious vault. It is perhaps spread across countless tiny relationships in the fabric of reality. Where exactly that pattern lives, even now, may be more complicated than we usually assume. Again, no claims, no promises. We are not saying souls live on cosmic boundaries. We are noticing quietly that nature has shown a recurring tendency to surprise us with where it keeps its records. The deeper we look, the more rooms we find. The deeper we look, the more the walls themselves seem to whisper that the picture is larger than it first appeared. If you walk through any modern physics textbook, you will find equations for almost everything: particles, fields, forces, curvatures, distances across galaxies, birthplaces of light. And yet, nowhere in those carefully arranged symbols will you find a clean equation for the most intimate fact in your life: the simple, undeniable presence of your own awareness. You are reading these words or listening to them. Something is reading, something is listening. And science, for all its progress, has not yet figured out how to fully describe what that something is. The philosopher David Chalmers gave this puzzle its modern name. He called it the hard problem of consciousness. The easy problems in his framing are things like how the brain processes vision, how memory is stored, how attention is directed. These are difficult, but in principle, science can make progress on them by mapping mechanisms. The hard problem is different. It asks why any of these mechanisms are accompanied by experience at all. Why is there something it is like to see red, to feel warmth, to be afraid in the dark, instead of just behavior happening in the dark? In the science of the mind, there is an emerging family of theories that try to bring consciousness within reach of measurement. One of them, integrated information theory, suggests that consciousness is related to how much information a system integrates, how richly its parts depend on one another in a unified way. It is an ambitious attempt, mathematically refined, philosophically provocative. Some find it deeply promising, others have serious objections. None of it has been definitively confirmed. Other approaches focus on global workspaces, predictive processing, or higher-order representations. Each captures something interesting. None has settled the debate. The honest summary is this. After centuries of philosophy and decades of intense neuroscience, no theory yet explains, in a fully accepted way, why subjective experience exists, or why it has the qualities it has. What does it mean to live inside this unfinished science? It means that the very thing through which you experience everything else, including this script, remains, in a deep sense, mysterious. The universe seems to have allowed something extraordinary to happen here. From silent atoms, blind forces, and patient time, awareness has emerged, quietly, stubbornly, persistently. You can sit with this in different ways. You can feel intimidated by the mystery, or you can feel held by it. Many late-night thinkers have found something almost steadying in the realization that the science of mind is still young. It means that even the deepest experts admit they do not yet fully understand what you are. The simple presence of your own awareness is, at the moment, beyond the equations. This humility matters when we wonder about endings. If consciousness is something we do not yet fully grasp, we should be careful about claiming we fully grasp what it means for it to begin or to cease. The story we usually tell about awareness coming and going may be one chapter of a much larger book, most of which has not yet been written. This is not a doorway to wild claims. It is a doorway to careful wonder. Tonight, as your awareness softens towards sleep, notice how strange and intimate it is to be aware at all. Science has not yet finished explaining you, and there is perhaps something gentle in being something that not even the universe's smartest equations have fully described. In daily life, death feels like a sharply defined word, a line between one state and another. But when you look closely at how physics describes the world, you find that there is no clean equation that draws this line. The deepest theories we have about particles, fields, forces, and energy do not contain a special symbol that means alive or no longer alive. They simply describe how matter and energy move and interact. The boundary is drawn by biology, by medicine, by language, by us. This does not mean death is not real. It is real in every way that matters in human experience. It changes lives. It rearranges futures. It transforms families. We are not pretending otherwise. But it does mean that, from the strictest viewpoint of fundamental physics, what happens to the body at that moment is not a sudden snap. It is a transition, slow and complicated, in which an enormously complex pattern begins to lose its ability to maintain itself. Even after the heart stops, even after breathing ends, processes do not all stop at the same moment. Cells continue, briefly, to consume energy. Chemical reactions still occur. Heat continues to dissipate. The body, in a strict thermodynamic sense, does not abruptly leave the universe. It begins a long, complex process of equilibrating with its surroundings. The matter and energy that made up the living configuration begin a slow journey into other configurations. This is not a comforting fact in any cheap sense. It is not an attempt to soften something with science. It is simply an honest observation that the line we draw in language is not as crisp as the line we feel emotionally. Biology has practical definitions, useful for medicine and law. Physics, at its most basic level, has no equivalent. From its perspective, the universe just keeps doing what it always does. Energy flows, atoms rearrange, patterns dissolve, recombine, and continue. Many cultures and traditions have noticed, in their own ways, that the boundary is not as sharp as it sounds. Some have spoken of slow transitions, of stages, of layered partings. Modern science, in its own quieter language, agrees that there is no single mathematical moment at which a body crosses an instant frontier. There is a gradual loss of coordinated function, a gradual return of the body's components to the wider environment. We can feel the unease that such honesty can bring. Our minds want sharp lines. They want to be able to point and say, here is the line. Before this it was one way. After this it is another. But the universe, when looked at carefully, often refuses to draw such lines. Day and night, child and adult, awake and asleep, all blend at their edges. so does this. What lives, in many spiritual and philosophical traditions, on the other side of that fuzzy boundary is a question physics does not try to answer. Equations do not speak of meaning or of soul or of whatever might or might not lie beyond. They speak only of what happens at the level of particles and fields. That silence is not a denial. It is simply a quiet acknowledgement that those questions belong to a layer of human experience beyond what current physics has the tools to address. So we hold the line gently. The body's story does not end as crisply as our language suggests. The deeper questions remain open, and the universe, in its calm way, simply continues to unfold. There is a curious feature of how you experience reality, and once you notice it, it is hard to unsee. You only ever experience the situations in which you exist to experience anything. This sounds almost trivial, like a tautology, but woven into modern physics and philosophy, it has a name and a quiet weight. It is sometimes called the anthropic principle, and it refers to the way observers can only find themselves in conditions that allow observers to be there. Think about the universe at large. It has many constants and properties. The strength of certain forces, the masses of certain particles, the smoothness of its early state. Many physicists have noticed that if these numbers were slightly different, stars might not form, atoms might not bind, complex chemistry might not arise, and life as we know it might be impossible. The universe is, in some sense, finely tuned for the existence of structure, including the kind of structure that produces minds. There are several ways thinkers have responded to this. Some take it as a sign that life is rare and precious, the result of remarkably hospitable conditions. Some propose that there may be many universes or many regions with different properties, and we naturally find ourselves in one capable of sustaining us. Others are cautious about all such conclusions, noting that we have only one universe to study. The debate is genuine, and no one position is finally settled, but behind all of this is a softer, more personal version of the same idea. It is not just that observers exist where conditions allow observers, it is that you, specifically, only ever experience the moments in which there is a you to experience them. The story of your life is told from inside the parts of reality where the story can be told. Everywhere else is silent from your viewpoint, simply because it never produced your awareness in the first place. Place this gently against the picture from earlier chapters. In a many-branched picture of quantum reality, only some branches contain a continued you. From inside, you only ever live the branches in which you are present. The other branches are not part of your felt narrative. They are silent threads in the wider weave, holding their own outcomes you cannot directly know. This is sometimes called observer selection. It is not a magical force. It is a structural feature of being a perspective in the first place. You cannot have a memory of a moment in which you were not there. You cannot have a feeling about an experience that never happened to you. The geometry of being someone selects, very softly, for the kinds of moments you can witness. Some find this idea unsettling. It can feel like a trick, a kind of self-curated view of the cosmos. Others find it strangely comforting. Whatever the deeper reality looks like, your felt life is, by its very nature, populated by moments in which you exist. From inside, that is the only kind of life you can lead. We are not claiming this proves any particular metaphysical view. The anthropic principle is a tool for careful thinking, not a sudden answer. It reminds us, however, that the universe's vastness contains many silent rooms, and that you, by simply being aware, are always standing in one of the few that has been lit. Tonight is one of those lit rooms, and here you are, gently, still inside it. In the world we usually move through, walls are walls. If something stands between you and a place you want to be, you cannot simply pass through. You go around, you open a door, you climb, but at the smallest scales of nature, this common sense rule loosens in a quietly astonishing way. Particles in the quantum world can sometimes appear on the other side of barriers that, in classical physics, they should never be able to cross. This is called quantum tunneling. It is not science fiction. It is a real, measured phenomenon woven into the everyday workings of the universe. The fusion in the cores of stars, including the sun whose warmth eventually reaches the surface of your skin, depends on tunneling. The flow of certain electrical currents, the behavior of certain microscopic devices, the radioactivity of certain elements, all rely on this strange permission that quantum physics gives to tiny particles. Here is the gentle picture. Imagine a small ball that does not have enough energy to roll up and over a hill. In our everyday world, it is stuck. It will never reach the other side. But in the quantum world, the corresponding tiny particle has a small chance, sometimes vanishingly small, sometimes not, of being found on the far side of that hill, as if it had somehow slipped through. The barrier is real, the particle is real, and yet the wall is not as impassable as it seems. This works because, at the quantum scale, particles are described by waves of possibility, not as small marbles with definite locations. Those waves do not stop abruptly at barriers, they reach into and through them, becoming smaller but not vanishing. Sometimes, in a tiny but measurable fraction of cases, the particle is found on the other side. The impossible turns out to be only the improbable. Now lift this gently into the larger conversation we have been having. We have been talking about endings, continuities, branches, patterns, and here, in the deep mathematics, we find one more soft hint. Walls that look absolute, when examined carefully, sometimes turn out to be only mostly impassable. Limits that seem total can have in the equations a tiny persistent leak of possibility. This does not mean that human bodies tunnel through walls. The probabilities for large, complicated objects are so unimaginably small that you would have to wait far longer than the age of the universe to ever see anything like that happen. The everyday world is solid for excellent statistical reasons, but the deeper principle is worth carrying with us gently. The fabric of nature is built on patterns in which certainty and possibility are layered together. Even what looks impossible at our scale is, at the very smallest scale, often a matter of how rare, not how forbidden. So perhaps, in the quiet way that physics whispers its truths, this is a small invitation to soften the walls in our minds, to loosen the grip of phrases like completely impossible when applied to the unknown. The universe has shown over and over that what we once called impossible was sometimes only deeply improbable, and that there are more pathways through the world than our intuition can comfortably picture. This is not a promise, just a gentle hint woven through the equations. The walls are real, but they may not be as final as they seem. In the 19th century, the French mathematician Henri Poincaré proved something quietly astonishing about certain kinds of physical systems. He showed that, given enough time, a closed system with a finite number of states will eventually return arbitrarily close to a state it has been in before. This is sometimes called Poincaré recurrence, and although it is a mathematical statement about idealized systems, it has captured the imagination of thinkers ever since. The picture is gentle and strange. Imagine a vast room filled with countless particles, all bouncing and interacting, following the laws of physics. Even though the system seems chaotic, if you wait long enough, an unimaginably long time, the particles will eventually drift back into an arrangement very close to one they have previously held. Patterns that seem to scatter forever, in this view, may in principle gather again. It is important to be cautious here. Poincaré's theorem applies most cleanly to specific kinds of systems, and applying it to the entire universe is not straightforward. Our universe seems to be expanding. Its boundary conditions are debated. Whether it counts as the kind of closed system the theorem describes is itself a topic of theoretical discussion. So this is not a settled prophecy. It is a beautiful mathematical hint that in idealized models, configurations can recur. Still, take a moment to sit with the picture. In some interpretations, given a vast enough span of time, what we currently feel as unique configurations of matter and history could, in principle, almost repeat. Almost. Not as a perfect copy, but as something extraordinarily similar, like a melody resurfacing in a new movement of a long symphony. This is, of course, a thought experiment more than a practical claim. The amounts of time involved would dwarf anything humans can meaningfully picture. The universe's actual fate may not allow such recurrence at all. Many cosmologists work with models in which the cosmos heads toward a quiet, smooth state, in which structures dissolve forever. Others explore models in which something else, perhaps unknown, replaces the current expansion. We are deep in the territory of speculation, but the soft speculative whisper of Poincaré recurrence is worth holding gently. It is a reminder that, in at least some of the well-defined mathematical models physicists explore, the idea of an event being lost forever is not as automatic as our intuition assumes. Patterns can fade, scatter, and yet, in principle, gather again in similar forms. The universe's mathematics allows for the possibility of return, even if it never demands it. What this offers, at most, is a quiet softening of finality. Not a promise of literal eternal return, not a doctrine, only a hint that even very pessimistic intuitions about a one-way march of patterns into oblivion are not the only conclusions the equations have to offer. Some have wondered if our deep emotional sense that nothing is ever truly lost, that beloved patterns somehow persist beyond their visible time, is perhaps an echo of something the universe is also expressing through its mathematics. We cannot make that bridge solid. We can only stand beside it, looking at both shores, noticing how the human longing and the abstract theorem rhyme, however gently. Tonight, time stretches around your room, long and patient. Whether the universe's arc is straight or curved, finite or returning, it carries you on its slow, careful current. If you imagine yourself, just for a moment, as a single point moving along a single line, you may notice how thin that picture feels. A point, after all, has no width. A line has no breadth. And yet from inside, your life has texture, ambiguity, branching possibilities considered and abandoned, paths chosen and never returned to. Even your sense of yourself feels less like a point and more like a layered field of impressions, memories, half-realized selves. In quantum physics, there is a related idea, though it must be held very gently. In the broader wave function of the universe, every possible outcome of every interaction may, in some mathematical sense, have an amplitude, a weight, a contribution to the larger structure. In certain interpretations, what feels to us like the one path actually lived is just the path that decoherence and our perspective have allowed us to experience. Other paths, in those interpretations, exist as quiet, parallel histories elsewhere in the structure. Decoherence, in simple language, is the process by which a quantum system interacts with its environment and loses the ability to show its many possibilities all at once. The wider world, with all its noise and complexity, brushes against the quantum system, and the delicate superpositions break down into the appearance of a single classical outcome. This is part of why we do not see large objects in obvious quantum blends. Their interactions are too rich. Their possibilities are too quickly washed out. If we let this gently shape our picture of identity, something soft emerges. Perhaps you are not just one note. Perhaps you are something more like a chord, a central, sharply audible note for the path you actually experience, surrounded by softer, fainter notes for the paths that the math allows but you do not feel. Most of these would never form a continuous story. Many would not even add up to a self. But the wider field of possibilities in this interpretation is not nothing. This is not a promise that every alternative life is hidden behind some invisible curtain. We do not know that the many worlds-like interpretations are correct. The traditional view, in which only one history is real, remains a respectable position. We are not arguing for one over the other. We are noticing gently that even the most familiar single-life picture sits inside a debate that has been quietly humming through physics for many decades. What you feel as the felt center of your life, is a particularly sharp and continuous version of a pattern. Around it, in your imagination, are the lives you might have lived. In some interpretations of physics, those imaginations are not entirely without weight. In others, they remain pure imagination. Either way, the realization is gentle and humbling. The self is wider than it looks. There is something quietly comforting in not insisting that the line of your life is the only thing that matters. The relationships you have, the love you have shared, the small choices you have made with care, may belong not just to one line, but to the broader chord that you, as a possibility field, have helped sound across the unfolding music of reality. So the self may be less like a single voice and more like a soft harmonization across possibility. Tonight, you are one note inside that harmonization, held by what you experience, surrounded by what you can only imagine, resting inside something larger than any single thread of life. There is a quiet symmetry hidden in most of the equations physicists use to describe the world. If you take the laws of motion, the laws of electromagnetism, the equations of quantum mechanics, and play them in reverse, in mathematical terms, they still make sense. The math does not particularly mind whether time runs forward or backward. The same equations describe a ball falling and the strange image of a ball rising back up into the hand. The same equations describe particles scattering apart and particles converging back together. This is sometimes called time reversal symmetry. It is one of the deepest puzzles of physics, because if the equations themselves do not care about the direction of time, why does the world we live in feel so one way? Glasses break, but they do not unbreak. Memories form from the past, not from the future. We grow older, not younger. The universe seems to march in one direction, even though its underlying laws do not insist on it. Physicists usually trace this asymmetry to the second law of thermodynamics, which speaks about entropy, a measure of how spread out and disordered the energy of a system has become. Roughly speaking, the universe tends to move from more orderly configurations toward less orderly ones. This is why broken glasses do not gather themselves. It is why heat flows from hot to cold. The arrow of time, in our experience, is closely tied to this statistical tendency of disorder to grow. But notice what this implies gently. The deep fundamental laws of physics, the bedrock equations, do not contain a strong directional preference. The one-way feel of time is more like a statistical pattern at our scale than a fundamental command in the math. At the smallest layers, time's flow becomes softer, less obvious, less absolute. Some have wondered, carefully, what this might mean for endings. If the underlying equations treat past and future more even-handedly than our intuition does, perhaps the sharpness we feel about before and after is partly a feature of the scale at which we live. Not an illusion exactly, but a kind of summary, a coarse-grained story over a finer texture that does not see the world quite the way we do. This does not magically dissolve the felt direction of time. Your experience of moving forward is real and important. You should still set your alarm, eat your meals, and live as if tomorrow is coming. We are not suggesting otherwise. We are simply noticing, with quiet wonder, that at the deepest level, the math leaves room for a more symmetric description than our everyday lives suggest. In some ways, this is a comforting picture. The equations do not regard the past as gone in the harsh sense we sometimes do. They see it as part of the same fabric, still mathematically connected to the present. The moments you have lived are not erased from the equations, they are simply behind you on the path through a larger structure. You may not be able to walk back into them, but the universe, at the level of its fundamental laws, is in no rush to erase them. There is a question that has followed thinkers for as long as anyone can remember. Why is there something rather than nothing? Why does anything exist at all? Why is there a universe with stars, oceans, people, breath, hearts, and the soft hum of late-night thoughts, instead of an unbroken stillness with no story in it? This question is older than every philosophy we have, and physics, despite its remarkable progress, has not closed it. Modern theoretical physics offers some intriguing partial pictures, but they need to be held very carefully. Some physicists propose that what we call empty space is not actually empty. According to certain models, the vacuum is alive with fleeting fluctuations, tiny appearances and disappearances of particles, described by quantum field theory. The vacuum is restless, it has its own structure, it has energy, sometimes called zero-point energy, even when nothing else is around. Some theoretical models go further and explore how complex structure might emerge from such fluctuations. In certain conditions, over vast scales we cannot easily picture. These are serious areas of research, but it is important to be honest. None of these models have, in any settled way, answered the deepest version of the question. They describe how, under certain assumed conditions, certain patterns might unfold. They do not explain why the universe is set up to allow any of this in the first place. The why slips quietly behind the how. This is a place where physics is admirably humble. The equations describe what happens. They do not ultimately explain why there are equations at all, or why reality is the kind of place where equations apply. Even the most ambitious theories, when honestly examined, sit inside a deeper mystery they cannot fully step outside. Some thinkers find this frustrating. They want a final answer that closes the question. Others find it strangely beautiful. The mystery is not a failure of science. It is a feature of being conscious creatures inside a universe whose origins lie at the very edge of what we can examine. The question of why there is something rather than nothing also gently touches our smaller, more personal questions. Why is there a you instead of no you? Why does any particular pattern get to unfold for a while inside this vast, quietly humming reality? Physics does not answer these questions with a tidy proof. It offers instead an immense backdrop in which such questions can be asked, and a long history of careful uncertainty about how to begin. What we can say is gentle and modest. The fact that there is anything at all is perhaps the most remarkable observation any of us ever makes, even when we forget to notice it. The fact that there is a you here, breathing, thinking, drifting towards sleep, is a small miracle within a larger one we do not fully understand. Tonight, the universe is, and you are. Beneath that simple sentence sits a question without a complete answer. We can hold it without needing to resolve it. We can let it be one more strand in the night's quiet wonder. When you turn your attention inward to look at your own awareness, something strange happens. The looker is the looked at. The instrument trying to measure is part of the thing being measured. You are, in a sense, a small piece of the universe trying to understand the universe, from inside the universe. This creates a quietly recursive loop. Reality folds back on itself when consciousness turns to study consciousness. In mathematics, there is a famous result by Kurt Gödel from the early 20th century, sometimes called his incompleteness theorem. In very simplified terms, it says that any sufficiently rich mathematical system will always contain true statements that cannot be proved using only the rules of that system. Some truths in such systems live just beyond what the system can grasp about itself. This is not a flaw in math. It is a deep structural feature of self-reference. Physics is not exactly the same as a formal mathematical system, and we should not stretch the analogy too far. But there is a soft echo. Whenever a system tries to describe itself fully from within itself, it tends to run into limits. There are aspects of its own structure it can point to, but not fully close. The deeper the system, the more these subtle gaps appear. Now think of yourself in this light. You are part of the universe. Your brain is part of the universe. Your science is part of the universe. When the universe, through you, tries to understand itself completely, it is asking a creature inside the system to fully describe the system. There may be in principle parts of that picture that cannot be cleanly captured from inside, not because the universe is hiding them out of malice, but simply because of how self-reference works. This is not a depressing thought. It is in many ways freeing. The fact that we cannot fully close the loop of understanding does not mean we have failed. It means we are participants, not outside observers. We are inside the story we are trying to read. Some of the words in that story can only ever be felt, not fully proven. Many of the most honest scientists carry this humility with them. They know that even the best theories are tools for navigating reality, not final mirrors of it. They know that the listener inside the system has limits the system itself cannot fully describe from within. This gentle insight reaches into the question of endings too. Maybe the strange feeling that something about consciousness exceeds clean explanation is not a trick of the imagination. Maybe it is a faint echo of the deep fact that self-reference always leaves something just beyond reach. The fact that you can ask, "What am I, really?" is itself one of the most remarkable phenomena in the universe we know. Not a problem to be embarrassed by, not a failure of insight, a signature of being a piece of reality conscious enough to notice itself. So tonight, As you settle, let the loop be a friend instead of a riddle. Let the listener listen without needing to be fully described. The system has chosen, through you, to listen to itself a little. Step outside on a clear night, and you can sense, almost physically, how small you are. The sky stretches outward, the stars sit at unimaginable distances, and the universe seems to widen in every direction with no obvious end. Step inward, into the body, and the same vastness appears in the other direction. Inside every cell, vast numbers of molecules. Inside every molecule, atoms. Inside every atom, even smaller scales, eventually reaching what physicists sometimes call the Planck scale, where our current theories begin to dissolve. The Planck scale is unimaginably small. It is not just smaller than an atom. It is to an atom what an atom is to a small mountain, and even more. At those depths, our familiar ideas of space and time begin to lose their clean meaning. Theories suggest that the smooth fabric we usually picture may give way to something stranger, where geometry itself becomes uncertain, where the distinction between location and process blurs. At the opposite end, the universe extends across distances measured in billions of light years. Even light, the fastest messenger we know, has not had enough time since the universe's beginning to cross all of it. The cosmos is so large that some of its regions can never, in principle, send signals to others. Vastness in space and time is not metaphorical here. It is a measured property of the world we live in. You are squeezed between these two infinities. The smallest scales below you are dizzyingly tiny. The largest scales above you are dizzyingly vast. And here, on a thin shell of warmth and breath, you are aware briefly of both. Some find this realization frightening. Others find it strangely freeing. When you live deeply in the middle of so many scales, the importance of any single moment can either feel impossibly small or impossibly precious. Both responses are honest. At the same time, something subtle softens at the edges. At the smallest scales, time and identity become less fixed. At the largest scales, distances and durations stretch beyond what our minds were built to picture. The boundaries we feel between this and that, before and after, here and there, are sharp at our scale, but become hazier as we look much smaller or much larger. In a way, you live inside a layer of reality that emphasizes boundaries. It is the layer where rivers have banks, bodies have edges, mornings begin and evenings end, but it is just one layer. Above it and below it, the universe sings in a less divided voice. Energy moves, geometry shifts, patterns merge and separate at speeds and scales no daily life ever directly meets. The vastness above and the vastness below do not erase the gentle preciousness of being here. They simply remind us that here is one small chapter in a book larger than we can read. The boundaries that feel hard during the day soften when you let your attention drift across scales, and the meaning of ending becomes less clearly outlined the wider your view becomes. You are a creature of the middle scales, looking outward and inward at once, and from that quiet middle, the universe stretches gently in every direction. There is a beautiful pattern in the history of science. Each major discovery, each elegant new equation, each crisp experiment, instead of closing the great questions, has tended to open new and deeper ones. Newton's laws explain the motion of planets but raise the question of what gravity really is. Maxwell's equations united electricity and magnetism but pointed toward the strangeness of light. Einstein's relativity reshaped our picture of space and time but called for a still deeper theory. Quantum mechanics succeeded brilliantly while puzzling everyone, including its inventors. Every level of clarity has been a doorway into a wider, more humbling unknown. In one way, this might sound discouraging. If the mystery never shrinks, what is the point of all this work? But many have found exactly the opposite to be true. The fact that the mystery refuses to shrink is in itself a kind of quiet comfort. It means that the universe is genuinely vast in its depth, not just in its size. It means there will always be more to wonder about. The river of curiosity has no dry season. Many of the deepest thinkers have noticed that the more they learned, the more they felt how much they did not yet understand. The well never ran out. Each answer revealed a new shape of question. Reality, like a kindly host, kept inviting them deeper into a house with more rooms than they had imagined. This is part of what makes the simple act of being conscious so extraordinary. You are a small, brief, breathing creature inside a universe whose mysteries cannot be exhausted, even by all the science we have built. And yet, that universe somehow permits you to think about it, to ask, to wonder, to follow its hints into stranger and stranger places. That ability is not a trivial gift. It is in this spirit that the deepest questions of life and ending can be held. We do not need to feel embarrassed that we do not have neat answers. We are part of a long lineage of careful minds, all of whom encountered the same humbling realization. The fabric of reality, at its deepest level, exceeds what any single thinker, theory, or moment can capture. Sometimes, when a person lies awake and feels the weight of unanswerable questions, the temptation is to demand a final, certain reply, to insist that the universe explain itself, and to feel anxious when it does not. But there is another way to live with these questions, to let them be companions, to carry them gently, to notice that the mystery is not against you, it is the very landscape you live inside. Tonight, you do not need to settle the great questions. You do not need to solve the universe before you sleep. You are allowed to wonder and then to rest. The mystery will still be here in the morning, patient, beautiful, refusing to shrink. And that is, in its quiet way, a profoundly tender thing for the universe to be. After all these chapters of equations, models, and gentle speculations, it is worth taking a small step back to notice something simple and important. Physics, for all its power, describes behavior. It tells us how things move, how energy flows, how patterns evolve. It does not tell us what any of it ultimately means. The equations can say how a star burns. They cannot say what it feels like to gaze at one from a quiet field at night. The equations can say how a heart beats. They cannot say what it is to love. This is not a weakness of physics. It is its honesty. Equations are tools for tracing patterns. They are not designed to answer questions about purpose, value, or ultimate meaning. When physicists speak about what their work covers, the most careful ones are clear that science describes how the world behaves, not why it exists in the deepest sense, and not what role any creator or guiding principle might or might not play behind it. These are layers of question that lie outside the domain of equations. So when we say things like, "The math has no instruction for endings," we must be careful not to read it as a final statement about ultimate meaning. It is only a statement about a particular layer of description. There are other layers, other questions, other ways of asking what a life is and what it might mean. Religious traditions, philosophical reflections, personal experiences, and quiet inner intuitions have all explored these questions in their own ways. Science neither confirms nor erases them. It simply does not speak in their language. There is freedom in this. The fact that physics is silent on certain questions means we are not forced into any particular conclusion by science alone. The deep mystery of existence remains an open space in which different ways of seeing can dwell together. Some find meaning in the patterns themselves. Some find meaning in something beyond the patterns. Some sit honestly inside uncertainty. The equations, at their humblest, allow all of these. The voice that says, "I do not know," is often dismissed as weakness. But in matters this large, it can be one of the wisest things a thinker can say. To stand inside an enormous unknown without pretending to a false certainty is itself a kind of strength. It keeps the heart soft and the mind awake. So tonight, we let the equations rest where they belong, as careful descriptions of patterns we have observed and tested. We let the deeper questions remain open. There may be more than physics. There may be less. There may be something woven through everything that no equation can capture. We do not need to decide here in the dark by ourselves. The wonder is enough company. For much of human history, people have wanted complete answers. We have built religions, philosophies, scientific theories, all in part to find some sense of completeness. And again, life has gently revealed that complete answers are difficult to come by. Even the most powerful frameworks leave edges, gaps, questions still unfolding. Living inside incomplete knowing is in many ways the natural human condition. This is not a failure of the mind. It is a feature of being a finite creature inside a very large reality. Every generation has lived with questions it could not fully resolve. Every wise tradition has, in some form, acknowledged that mystery is part of the texture of life, not just a temporary delay before final clarity arrives. To be human is to know some things, to suspect more, and to live alongside many open questions. There is, for many people, a kind of quiet anxiety attached to this. The wish for closure can be strong, especially at night when the mind has fewer distractions. Unanswered questions can begin to feel heavier than they really are. Worries about meaning, about what comes after, about what truly matters can press in on the quiet. But notice something gentle. The very fact that you can ask these questions is itself a sign of how rich your inner life is. Animals seem to live more inside the moment, less troubled by long horizons. The capacity to wonder, to ask about your place in the universe, to consider possibilities your daily life never directly meets, is one of the most remarkable parts of being human. The questions are not your enemies. They are a sign that something deep in you is alive and curious. There is a soft practice, available to anyone, of holding open questions with friendliness instead of fear, of letting "I do not yet know" become a quiet companion rather than a threat, of allowing the great mysteries to sit in the room with you, like trusted friends who do not need to be answered to be welcome. Tonight, you do not need to figure out the universe. You do not need to choose a final theory. You do not need to settle whether time is a line or a texture, whether worlds branch or do not, whether consciousness is fundamental or emergent. You can sit with all of it, gently, without any pressure to decide. In time, perhaps you will find your own ways of making peace with these questions. Perhaps the answers will come slowly, in different voices, from different sources, or perhaps the questions themselves will become the deepest part of your life, woven into the way you love, the way you think, the way you rest. For now, the comfort of unfinished knowing is enough. The universe has been unfolding for a very long time, full of mystery, full of pattern, full of quiet hospitality to creatures who think and wonder. There is room here. There is room for you. Set aside for a moment all the heavier questions. Set aside the equations, the branches, the boundaries, the unsolved equations. Come back to this, the simple present fact of you lying here in this room on this night. Your body is a remarkable arrangement, star-born atoms slowly and patiently organized into cells, tissues, organs, all working together in countless tiny ways to support the single continuous experience of being you. The energy that warms you tonight was, not long ago, sunlight. The breath in your chest connects you to vast cycles of air and life. Your awareness sits inside this network, quietly aware that any of it is happening at all. In the strict language of physics, none of this material will ever be truly destroyed. The substance of you will continue in other forms when this particular configuration eventually softens. The energy that powers your thoughts will not vanish. It will flow onward into other patterns, into wider processes. The conservation laws we explored earlier are not metaphors. They are descriptions of how reality actually behaves, but you do not have to think about that tonight. Tonight you can simply notice that for now the pattern is here, the breathing is happening, the warmth is present, the mind is gently humming. The remarkable arrangement that is you is, right now, fully participating in the universe's long, quiet song. It can be easy, in moments of difficulty, to feel like a small, vulnerable thing in a vast and indifferent cosmos. But the cosmos is not indifferent in the simple, harsh sense. It is patient. It is generous with its building blocks. It has again and again allowed extraordinary patterns to emerge from very ordinary ingredients. You are one of those patterns. Tonight, that pattern rests. If you would like, you can let your attention move softly through your body. Notice the weight of your head, the the gentle release of your shoulders, the slow rise and fall of breath. Each of these is held by a vast network of physical laws and processes that have been at work since long before you were born, and will continue long after this particular configuration changes. You are part of that continuity, not as a promise of permanence in any one form, but as a small, real participation in the larger flow. The universe is not trying to lose you. It has woven you in. The atoms in your hands, the warmth in your chest, the quiet attention behind your eyes, all of it belongs to something that does not, in any fundamental sense, know how to throw things away. Tonight, that may be enough. Not a complete theory of everything, just a soft awareness that you are held, materially, energetically, mathematically, by a universe that has always preferred continuation. So now, slowly, we begin to let it all soften. The thoughts, the questions, the wonders, they are not going anywhere. They will be here gently in the morning, and on other nights when you need them. There is no need to hold any of them tightly now. There is no need to solve a single thing. Let your body grow heavier on whatever it rests on. Let the small muscles in your face loosen. The small tensions in your hands release. Notice your breath without changing it, just letting it move in its own quiet rhythm, in and softly out, in and softly out. Whatever the equations say, whatever the branches do, whatever the universe is doing at its deepest levels, you are allowed to rest. The wider story will continue without your effort tonight. The atoms inside you, ancient and quiet, will go on humming. The energy that warms you will keep flowing through the patterns of your cells. The pattern that is you will be gently maintained while you sleep, as it has been so many nights before. You do not have to figure anything out. You do not have to decide what is true about endings, about worlds, about awareness. You can simply let yourself be part of the night, part of the long, slow exhale of a universe that knows how to hold its creatures. If thoughts arise, let them pass like soft clouds moving across a calm sky. They are welcome. They are not a problem. You do not have to chase them or push them away. Just let them drift, the way everything in the universe drifts, gently, through its own quiet patterns. The room around you is here. The bed beneath you is here. Your breath is here. And in some quiet way, all the vast, gentle continuations we have spoken of are here too, held in atoms, in energy, in patterns, in the simple, unanswered wonder of being. You are safe to soften now. You are safe to let go of the day. You are safe to trust the night. The same physics that has been described in these chapters is, even now, holding you, not coldly, not mechanically, but with the quiet steadiness of laws that have been at work for billions of years. You are not a small accident in an indifferent cosmos. You are a brief, beautiful pattern inside a larger story that does not know how to stop. Whatever happens next, in any branch, in any chapter, in any version of the equations, this moment, you here, breathing, is part of something gentle and ongoing. Let your eyes stay closed. Let your thoughts grow slower. Let the pull of sleep meet you softly, without resistance. The universe has been doing this for you, in some form, every night of your life. You can trust it tonight as well. Drift now, quietly, gently, into the rest that is, in its own way, just another version of the long, kind continuation we have spent these hours wondering about together. Sleep gently, continue gently, be gently. The quiet has you.